Okay guys, in this screencast I will be demonstrating how to use the Geometer Sketchpad software to create a real-world complex shape example. So let's get started. As you can see off to the left, we have all the tools the Sketchpad provides us with, and we're going to use the line segment tool to start making our complex shape. The one I will be demonstrating is a garden shed that most of you are probably familiar with. So just click on the blank screen and drag the segment wherever you want it to go to make it look like the real world shape you are making. So we'll make the shed come up to a point here and we'll connect it finally there. And if you don't like the way it looks originally, you can use the arrow function and resize it to get it to a more suitable height, length, and width that you like. So I'm going to move that there, and I think that drop this down a little bit. I think this looks a little better now. So here you go, it looks pretty good. Now after we've got the drawing done, we need to give this shed dimensions, and we can do that with the capital A. All we go is we go to a segment, double click it, and we'll give this a dimension of 10 feet. So there we go. We'll drop the 10 feet down. Now we need to give this side a height, double click, backspace, we'll make this 12 feet. And to find the area of this whole complex shape, we're going to need to know the distance from the very top point of the shed all the way to the bottom. And we will do that. We don't want to make a line right through it just yet, so we're going to use the segment tool to come out here and make a line showing that this new dimension will represent the height of it, so as not to interfere with the actual drawing. We'll connect these two. Just like that. Go back to the capital A, double click this. We'll make it 16 feet high. So now we've got all the dimensions drawn, and we need to break it into two different shapes now. And most of us can see, we all should probably be able to see that this needs to be broken into a triangle up top and a rectangle down below. So to do that, we're just going to go back to the segment tool and make a straight line right across here. And now we've got the triangle up top, the rectangle down low, and we can get to work solving the area of this shed. To show our work for this, we're going to use the capital A again, and we're going to make a large text box off to the right. So we'll hold the screen and just drag the mouse across, and we've got all this room to work with. So just use the keyboard to show your work here, and we're going to need to have two formulas. The area of a rectangle for down low, and the area of a triangle. So what is the area of a rectangle? Well, we know that the area of a rectangle is length times the width, and we know the area of a triangle. I'm going to drop this down, space it out a little bit. Area of a triangle, 1/2 base B times the height. So we've got the two formulas. You need to remember to show the two formulas, or however many formulas you will need to solve your real-world complex shape. Use that text box feature to show the area formulas that you're going to use. And eventually now we're going to show the work needed to be done to solve the area of this shed. So now we're going to start with the bottom rectangle. We're going to show the work needed to find the area of this portion. So what's the area of the rectangle? We know the area, to separate that, I'll make the area of the bottom rectangle so we won't confuse ourselves. That looks better. The area of the bottom rectangle. So we need it's the length times the width. Well, the width of this is just 10 feet, and the length, or the height, is 12 feet. So we'll simply do 10 feet times 12 feet. And that will equal 120 feet. And remember to put the squared. So we've got 120 feet squared for the bottom portion. Well, now we need to know the portion of this top triangle. So we know the formulas we've written up here is 1/2 the base B times the height. So we'll begin this area of the triangle. So we know we have to have the 1/2 times, well, what's the base of this triangle? The base is just 10 feet because it's congruent with the 10 feet that's on the bottom here. So 1/2 10 feet times, well, what's the height of this triangle? We need to know the distance from here to here. Well, we know the distance from the very top to the bottom is 16 feet, and we know the distance from the roof line of the shed to the bottom is 12 feet. So to find the height of this triangle, all we'll need to do is 16 feet minus 12 feet, which will give us 4 feet. So now that we know that, we can calculate this problem. So 1/2 times 10 feet, that equals 5 feet. And then 5 feet times 4 feet will equal. So now we have the two areas of the shapes that we've broken down of this complex shape. And to find the area of the entire complex shape, we would just need to add them. So we have 120 feet squared plus 20 feet squared. We'll add those two, and we know that the answer to this will be 140 feet squared. So now we have completed the area of this complex shape. Now when you do it after you've finished, you will present it in front of the class. Remember to have each group member show 3 items they contributed to this project. Remember that you need to have the area that you used to solve the complex shape and show all work needed to find the overall area. Remember to put your dimensions and use the correct functions. And I know you're all going to do a great job, and good luck with this project.